Today we're going to talk about on how do we evaluate limits of functions. So let's start. So what we need to do here is know these two basic formulas. So this will help us into evaluate the basic trigonometric functions. So let's say we have a limit of the function sine x over x as x approaches 0. It will always be approximately equals to 1. And we'll also have this formula, which is when the limit as x approaches 0 of the function 1 minus cosine x over x, that is going to be approximately 0. So even though it's approximate, we just made it equals to 1. So that's the formula. So upon noting that, let's just solve some basic trigonometric functions. So first, let's try this one. So what if we have a limit of the function sine 5x divided by x as x approaches 0. So in this video, what we're going to do is just approximate it to 0 because it can only be pi, right? Okay, so how do we solve this? So how do we evaluate this function? So what we're going to do is multiply this by 5 over 5. So that is equals to 1, so we do not need to worry about it. We just made it 5 over 5. We just made that 1 into a fraction. And what we're going to do is replace the denominator, so it will become equal to the 5x inside the sign. And we're going to let y is equal to 5x. So they're going to be the same. So if we do that, we're actually going to replace x by y too. So we get this. And now, so sine y over y is familiar, and that's going to be approximately equals to 1. So, so the limit as y approaches 0 of is going to be 1 times 5. So 1 times 5 is going to be 5. So this is the limit as x approaches 0 of that function. Now let's try this one. What if we have a limit of the function sine 2x over 5x as x approaches 0? So how do we will evaluate this? So what we're going to do here is just multiply this by, I think it's 2 over 2. So if we do multiply this by 2 over 2, what we're going to do is just replace the coefficient behind the x with 2. So they are going to be the same. So sine 2x over 2x, they are familiar. So let's just stay it like that. So that's going to be 1. And we'll leave it with 2 over 5. So 1 times 2 over 5 is going to be 2 over 5. So now let's try this one. What's the limit? About the limit as of the function sine 7x over sine 3x as x approaches 0. So how are we going to evaluate this if we have two functions on the numerator and denominator? So what we're going to do is multiply this by 7 over 7 and 3 times 3 and x times x. What we can do here is just replace the denominator of the first function of 7x, so they are going to be equal to 1. And that's we're going to do it also on the denominator on the function. And now what we got is 7 out of 3. So sine 7x over sine 7x is going to be 1, and also this is going to be also equals to 1. So if we're going to take its product, that's going to be 7 out of 3. So that's the function. Now let's try this one. So evaluate the limits of the function tan x over x as x approaches 0. So how do we do this? What we're going to do is just split them apart. So we're going to separate tan x into 1 over x, and using some identity in trigonometry, that's going to be sine x over cosine x times 1 over x. And now what we're going to do here is put that times 1 over x and then separate it from 1 over cosine x. Okay, so this is going to be 1, and if we do plug in the limit as x approaches 0 here, we're going to replace x with 0. Cosine 0 is going to be just 1. So what we got here is the product. What we do we need here is the product of 1 times 1. So that's going to be 1. So this is the answer. Now let's try this harder problem. So what's the limit of the function tan 4x over 3x as x approaches 0? So this is almost the same as earlier, but what we're going to do here is separate it two, and then what we can do is multiply this, I mean take it into its trigonometric identity. So that's going to be sine 4x over cosine 4x times 1 over 3x, and multiply this by 4 and 4. So we can just replace the denominator. So what we can have is sine 4x over 4x here. And we have, look at this, is 4. We still have 4 here. And we still have 3. Actually, we do not have 4. Got 1 over cosine 4x. And we got 4 over 3 here. Okay. Now if we're going to evaluate this, this is going to be 1. And this is still going to be 1. It's going to be 4 over 3. So the answer here is going to be 4 over 3. So it's not on the screen, but you can see it. Now let's try this one. So this is going to be sine x times sine x. So what we do here is just going to be sine squared x. It is not sine and then the inside function x squared. It is not that. So that's easy. And this is going to be different than earlier. So as we can see here that the power is not on the sine itself but on the x itself. So what we're going to do is multiply this by x and x over x. So we get is sine x squared divided by x squared, so times x. So this is going to be 1, and then what we can do here is just plug in the 0. So this is still going to be 0.